Welcome back, class. In this video, we'll be reviewing some of the basic properties of water and some of water's chemical components. So we'll be talking a little bit about water chemistry, which should hopefully be review and reinforcement at this point in time. So let's get started. So our learning targets today. By the end of this video, you should be able to recognize that the arrangement of atoms and electrons within a water molecule give each molecule areas of different charge or polarity. That's a big one. You should be able to predict the interaction of water molecules with one another regarding the attractions and repulsions between them. You could hopefully be able to distinguish between different types of mixtures and be able to identify various acids and bases. All right, so let's get started on unpacking this. Now, first, let's talk about the water molecule in general. Water is cool. Water has a lot of special properties, which is what allows water to be the solvent of life. And among them is water's awesome polarity. And this polarity comes from the way that the water molecule is arranged. So, a water molecule is polar because there is an uneven distribution of electrons between the oxygen and the hydrogen atoms. What that means is most of the electrons like to spend more time near the oxygen atom and less time towards the hydrogen atom. This is because hydrogen only has one proton, whereas oxygen has 8 protons. These 8 protons, the electrons want to spend more time near that positive charge. Remember, in this case, opposites attract. Opposite charges, like positive and negative, pull one another closer together. Because oxygen has more protons than hydrogen, the electrons tend to spend more time near oxygen. This is why the water molecule is polar, because water has a partial charge. What that means is oxygen is slightly negative and the hydrogens are slightly positive. I say slightly because technically the electrons are still being shared among them. We're talking about a covalent bond here, but the electrons spend more time near oxygen, giving it a more negative charge more often. Because of this, we have what are called hydrogen bonds. Hydrogen bonds occur because of the weak attraction between these negative and positive poles. Because of their partial positive and partial negative charges, polar molecules, like water, can attract each other. Similar to a covalent bond, but a little bit weaker. So remember that our oxygen here is slightly negative and that our hydrogens here are slightly positive. Because of that, the slightly negative oxygen is going to be attracted to the slightly positive hydrogen, creating these weak hydrogen bonds. Now, I call them weak because they can easily be broken, but they're also stronger than, let's say, van der Waals forces because they do hold together, which is why if you have a liquid, it kind of stays together, right? If you have a glass of water, it stays together. You can have a bead or a drop of water, and that's because of these hydrogen bonds. So the hydrogen bonding and the polarity of water is what gives it a lot of its really cool properties. Some of these properties are things like cohesion and adhesion, which you may have heard about, maybe heat capacity, and just the ability to be an excellent solvent. So we'll talk about some of water's awesome properties. The first one we're going to talk about is cohesion, and this is an attraction between molecules of the same substance. In this case, we're talking about the attraction between water molecules and water molecules. That's why if you just have a drop of water on, let's say, a penny, and maybe you did this activity last year in physical science, or maybe you'll do it this year in art class, you'll see that one drop of water will stay together nicely. It won't just splush everywhere. That's cohesion. Cohesion is also the reason why certain things like water bugs can walk or kind of float on top of water. And it's because of water's ability to kind of stick together. It creates this type of surface tension. So because of water's polarity and because of this hydrogen bonding, water is extraordinarily cohesive and can stick to itself quite well. The flip side of cohesion is adhesion, and adhesion is the attraction between molecules of different substances. This would be, for example, the attraction between water molecules and glass, or water molecules and the tree bark, or what would be called the xylem. Maybe you can think of it like capillary action. In little babies, if they go and have a blood draw, let's say, they're not going to stick a needle in them and pull out blood. That's because little kids are terrified. Instead, they're going to do a finger prick, and then they're going to take a tiny little glass tube and stick it on their finger and allow the blood to be drawn up through the glass tube, and that's called capillary action. This works because polar molecules, such as water, stick to the glass of the tube and are able to be drawn up. If you think to last year or any other labs you've done where you've poured water into a graduated cylinder, you'll notice that you get what's called the meniscus, right? So here's my beautiful graduated cylinder. If you haven't already seen my drawings, get used to them because they are fabulous. I do stick figures like nobody's business. So you will have what's called the meniscus, and this is this little dip right here, and mine's maybe a little more dramatic than you might see, but this is because adhesion, the adhesive bonding that takes place between the water and the glass is slightly stronger than the attraction or the cohesion that takes place between the water molecules themselves, which pulls them to the glass, causing this dip or meniscus when you draw up something or put it in a graduated cylinder. So in addition to cohesion and adhesion, water also makes excellent solutions and excellent suspensions, and has frequently been called the solvent of life. So just a recap, a mixture is a material composed of two or more elements or compounds that is physically combined but not chemically combined. So not to be confused with some of our chemical compounds. So we're talking about, let's say if you dump sand, salt, or sugar in a glass of water, right? Those are going to be some mixtures. And we're not going to dive too much into the heterogeneous or homogeneous mixtures that you learned about last, but we do need to talk a little bit about solutions and water as being one of the greatest solvents. So two major types of mixtures can be made with water. And again, we can make these types of mixtures with other things as well, but water is going to be our focus. And those are solutions and suspensions. So all the components of a solution are evenly distributed throughout the solution, and it's composed of a solute and a solvent. You can think of a solution like a homogeneous mixture. For example, salt water or sugar water would be examples of solutions. You'll make lots of solutions this year. The solute is the substance that is dissolved. So let's say we're going to make lemonade. Sugar would be the solute, or the lemonade packet would be the solute. And then the solvent would be the substance in which the solute dissolves. In that case, it would be water. Water is oftentimes the solvent in biology. So here's an example of a solution and really why a solution occurs. Let's take table salt, for example. When a crystal of table salt is placed in warm water, the sodium and chloride ions are attached to the polar water molecules. What happens is you pour a bunch of salt in some water, and then you stir it up really good. And all of these sodium chloride molecules and water molecules start to kind of break apart. And you can see here's, in this image here, you've got one big salt crystal of sodium chloride. And then as you stir and as the salt begins to dissolve, what happens is the little water molecules begin to surround each of the sodium and chloride ions, allowing it to be considered a solution. So you can see how that kind of breaks up. Now this works because remember, ions are charged substances. So we have charged chlorine and charged sodium. And then we have water, which is a polar molecule. Because water is a polar molecule, it has partial negative and positive charges. So now, again, we're seeing that attraction between negative and positive, which is what allows these solutions to occur. Now, we also have suspensions. A lot of biology's most important things are suspensions. A great example is your blood is a suspension. Some materials don't dissolve when placed in water, but instead they separate into pieces, super small pieces, so they don't settle out too terribly easily, and blood is a great example. Now, I don't know about you, but I would consider blood essential for life, considering, it flows through your veins. So blood is an example of a suspension of your blood is made up of primarily water, but the movement of water through your veins allows the parts of your blood, such as red blood cells, white blood cells, and plasma, to constantly be suspended. It might look like a solution, but a lot of the components of your blood aren't technically dissolved. In fact, if you look at your blood under a microscope, you can see some of this. Whereas if you look at salt water under a microscope, it might not be as easy to identify. So, for example, if we need your blood and we need to separate it out into its components, because it's a suspension, we can actually do that quite easily. So when you go and you donate blood, your blood can be separated into its various components, red blood cells, white blood cells, plasma, platelets, all of that kind of stuff, because it's a type of suspension. All right, so in addition to being able to have these awesome properties such as adhesion and cohesion, being a great solute, allowing suspensions to occur, water also gives us acids and bases and this awesome thing called the pH scale. Water is neutral, and that's because it can easily be converted back and forth into its hydrogen and hydroxide ions. And in fact, in pure water, only about one molecule in every 500 to 600 million molecules is going to split up into its ions. But when we do have a heavy number of hydrogen ions or a heavy number of hydroxide ions, we can get these things known as acids and bases. We can measure acids and bases on this thing called the pH scale. On the pH scale, 7, which would be right here, would be considered neutral. That's where water would fall. If you were acidic, you'd be down here in the 0, and if you're basic, you'd be up here at the 14. So it goes from acidic to basic as you move up the pH scale. So the pH scale ranges from 0 to 14, and hopefully this year you'll get an opportunity to play with some pH strips and test some pHs of common household substances. At a pH of 7, the concentration of hydrogen ions is equal to the concentration of hydroxide ions. Hydrogen ions are abbreviated H+, which, what does H+ mean? It indicates that we've got a cation that has a slightly positive charge. And then hydroxide ions are abbreviated OH with a minus. And remember, what's a minus mean? It means we're an anion. We have a negative charge. So some things to keep in mind. So when we're neutral, we've got an equal number of both of those, and that is where water sits. Now, if we're an acid is going to be any compound that forms primarily hydrogen ions in a solution. What I have for you here is HCl, or hydrochloric acid. It's called hydrochloric acid because it splits up into its hydrogen and its chlorine components, which creates an unbalanced number of hydrogen ions. What happens is basically we can cut off this hydrogen right there, and it will create hydrogen ions and chlorine ions. And it's an increase in these hydrogen ions that is going to cause a decrease on the pH scale, which is going to make an acid. Now, on the flip side, a base is a compound that produces hydroxide ions in a solution. This would be sodium hydroxide, or NaOH. You might know this as its common name, lye, and it's often used to make soap. What happens is this OH is going to break off and give us an OH minus, and this sodium is going to break off and give us an Na plus. It's an increase in these hydroxide ions that are going to give us our base, moving us up the pH scale. Now, acids and bases are really cool, but certain things like your body prefer to be in the neutral range. Remember, it goes back to that idea of homeostasis, right? A constant internal temperature. Well, your body is primarily made up of water, making you primarily neutral, and your blood too is neutral. And there are certain components of your body that might be more acidic or might be more basic, but in general, your body likes to be neutral. And that's where these things called buffers come into play. The pH of fluid within most cells in the human body has to be kept between 6.5 and 7.5, which is about neutral. Buffers are weak acids or weak bases that can be mixed with substances, allowing the pH to stay moderately neutral, thus allowing us to maintain homeostasis. What happens is you might have an acid or a base, but you want it to be neutral. So let's say you have an acid. You could add a weak base to it to help neutralize this acid. The reverse is also true. Let's say you have a base. You could add a weak acid to neutralize this substance. So let's recap. Can you recognize that the arrangement of atoms and electrons within a water molecule give each molecule areas of different charge or polarity? That is, do you understand that electrons spend more time near the oxygen atom? Do you know why that is? Can you predict the interaction of water molecules with one another regarding the attractions and repulsions? That is, if I give you, let's say, 5 water molecules, could you attach them to one another to make water? Can you distinguish between different types of mixtures? For example, things like solutions and suspensions. And do you know what the difference between them is? And are you able to identify acids and bases? Do you know what makes an acid and a base? Do you know the difference between a hydrogen ion and a hydroxide ion? If you're still struggling with those, either review the video, check out your textbook, or check out your notes from class. And as always, feel free to ask questions. So I hope this video has been great for you, and I will see you next time.